My conversation today, of course, is a little bit about space, a little different spin. My name is Pratish. I'm the general manager of Aitech, based out of Los Angeles. So we'll talk about space, a little bit different than some of our topics that we've had before. And it's going to be less technical. So we've had a lot of great presentations, a lot of technical presentations, and a lot of presentations about capabilities. So let's talk about space. And I'm going to begin with a little marketing slide here. Now, this isn't something I created, but I think it was 1957 when Sputnik 1 was launched. And 1958 is when Explorer 1 was launched. That was a while ago. I have to admit I wasn't around at that time, but over that time, and literally over 50 to 60 years since then, we've put humans on the moon. And then we've seen launches grow at a fairly slow rate. You see from 1974 onwards till roughly about 2017, the number of space launches and space platforms that are going up there are quite minimal. It's barely made a dent in the market, So why would you build solutions? Why would you build space electronics? Why would you embark on a business that, has very low volume? But what you see in this graph is an inflection point that began around 2017. And as you go on into the future, and it's compressed a bit to try to fit into a slide, is, over the next few years, there's a dramatic growth in the industry. And in some sense, we're all living that growth right now. And I'm excited to talk about how we can take advantage of that, not by inventing something new, but by leveraging what we already know. So we break up the industry in two parts. We got the Space 1.0 part, and then we got the Space 2.0 part. For the bulk of the 50 or 60 years since our launch of the products, launch of the space race and the space economy, we've lived in the Space 1.0. And that's been driven by incredibly high cost, expensive solutions, driven by the fact that getting something into space takes a lot of effort, takes a lot of money. Launch costs weren't measured in tens of millions, but measured in hundreds of millions, approaching $500 million. So if you're going to spend a great deal of money to get some asset up into space, you're going to spend a great deal of money and effort to make sure whatever you procure, whatever type of space-rated digital electronics is also going to work. You're not going to be driven by trying to save $50 or $1,000 or $500,000. You got to make sure it works, because a failure in space, and you spent $250 million, getting that asset in space, it's going to require a lot of explaining. So for a lot of the business at Aitech, we've been promoting space products for over 20 years. And a lot of that's been driven by customized solutions. A lot of NRE work, huge amounts of NRE work in some cases for very low volume business. It's a unique proposition, takes a lot of effort, takes a lot of time, and takes a lot of people to do. Over the last few years, we've seen that change. And the change is driven by a lot of external macro market-driven changes. Specifically, let's look at the launch cost. What cost maybe hundreds of millions of dollars to launch into space, into close to $500 million, now may cost tens of millions of dollars to launch. So now all of a sudden, getting an asset into space isn't driven by how expensive it is to get up there. It's like now I can launch something into space and not view the launch cost as a driving factor in the overall expense of my asset. So all of a sudden, literally overnight, the ability to launch something into space becomes commonplace. And that overnight also is changing how we view the space business. And from my perspective, Aitech's perspective, and I think what we want to share with everyone, we look at space of the future and Space 2.0, driven a lot by the Mil-Aero business, and less about very customized, very NRE, very unique space-driven business. And that's what we see the future of space going, is that type of a Mil-Aero type model versus a space-specific model. And this provides a few benefits. Benefits a few ways, not only in cost and availability, but also features. We don't look at the new space economy driven by some unique system. We know the new space economy wants the same things we have here on Earth, same things that the Mil-Aero folks want and their customers want. They want to be able to have a COTS infrastructure or a slightly modified COTS infrastructure that I don't have to spend millions or tens of millions of dollars designing. I want to be able to leverage all the strengths we have here on a Mil-Aero platform. I want to have connectivity no different than I have connectivity, on an air-based or a ground-based platform. I want Ethernet connectivity. I want to be able to connect all these systems on my space platform without some unique effort. I want to be able to have compute processing capability. We talk about the excitement of AI, machine learning, and all these sort of things in edge processing. No reason why you can't use that in space. It's not like there's some unique need in space that doesn't leverage the capabilities of artificial intelligence or machine learning. But no one's going to build a very unique, artificial intelligence platform to go into space. They want to leverage the same tools that, the military has been using on ground, sea, air-based platforms. So enabling space isn't about just lowering costs. Enabling space is about bringing the same capabilities and features that we are used to for decades here and making that available in space. So having AI processing equipment that's available, machine learning, network connectivity, computing capabilities, and having and building a full standard digital backbone that we have been talking about for a while for Earth-based platforms, that should be available in space. None of this is going to be possible if we all look at customized systems that just push our engineering, capacity to build something that's unique for very few units in space. But that does not exist anymore, as shown. There are hundreds, if not thousands, of platforms going into space, and we can work on building standardization across these platforms using our Mil-Aero knowledge. So I'll provide a few examples of something that we've seen happen. So first, very recently, just in the last few months, NASA launched 8 AI-based machine learning NVIDIA GPU systems on a platform called Loft ID. 8 of these systems were launched, they orbited, and then they re-entered. These systems were based on Mil-Aero technology that were adapted for space. No unique NRE effort was done, nothing like, oh my God, I'm going to build a custom AI engine here. This was a commercial off-the-shelf system. It was attached to cameras, and recording was done through the mission. Pure COTS based on Mil-Aero technology. Or again, another recent success, Artemis 1, that we all got to see with the Orion capsule. The Orion capsule also contained Mil-Aero-based technology. Intel, Xeon-based single board computer. Driving voice recognition technology within the Orion capsule itself. So this Intel, single board computer, in the case from an Aitech perspective, C878, is based on a Mil-Aero product. It was not a customized, built from scratch, space product. It was a Mil-Aero solution that has been proven on Mil-Aero platforms for a long time based on VPX that was placed in the Orion capsule and returned successfully. Or Virgin Galactic, as well, leveraging pure Mil-Aero COTS solution for the rocket motor controller. And this, again, isn't some unique space-rated, I went through all this upscreening and all this parts assessment and component analysis. It was leveraging Mil-Aero technology and using that in a space-rated application. So we're seeing more and more and more of our customers not look for specialized technology, but looking to us as a company, us as an industry, of how can we leverage the experience that we have from Mil-Aero into the new business that's coming through space. So I'll provide a few, in some sense maybe self-serving, but as examples of what we've converted from pure Mil-Aero products into space-qualified solutions. So what you see on the left on the screen is a Mil-Aero product that's been out for a few years. It's been on Mil-Aero platforms across the world. And that was one of the first products we took. And we said, let's go take that NVIDIA GPU-based solution and make that space-rated. And there was no custom NRE that we asked from the customer. It was based on the experience of what we need to do for space and be able to make sure and make some changes. Some of these changes are cosmetic, as they're kind of obvious when you look at the picture. Obviously, in space, you don't need fins because you're not going to have air-cooled, airflow over the fins to help cooling. So obviously, we can remove the fins. The chassis itself is not incredibly hermetically sealed. We actually need to have air kind of pass through because in the vacuum of space, we need to have the air escape from the chassis. So there's small holes in the chassis. And then, from an internal circuitry, there were some slight small modifications made in order to be able to recover. One of the things that questions that get asked is, in space, you may encounter an upset. How do you recover from an upset? Well, we made some small modifications to this in order to recover from an upset. And lo and behold, we finished the design of this product within a matter of months, and it's been sold, and as mentioned earlier, it's already been launched into space, without millions in NRE, without a lot of unique design, and it's based on a product that we've had in our portfolio for a few years. Another example, connectivity. As mentioned, you need network switches. You need network connectivity in space within the platform itself. And the same approach here. It took a proven network switch that's been part of our Mil-Aero product portfolio. And in a matter of months, made the conversions on it, adjusted the chassis, modified a little bit of the circuit card assembly to account for any recovery from upsets. We finished a round of testing. It's going to finish qual testing this month, and it's planned to get launched across a few platforms within the next 12 months. So again, we didn't ask for any unique NRE effort from customers or built a very custom platform. This is usually a standard COTS-based, Ethernet switch that provides equivalent functionality as you would get from any other type of a network switch. So the idea here, and the thing that you keep hearing is how do you leverage all of our experience that we have in the Mil-Aero domain, and how do you make that applicable for space? Yes, you can go embark on a lot of component analysis, procure incredibly expensive components, and build a very customized solution for a market that has a low volume need. But a lot of the space business is driven by the low cost to get up there, and in some sense, the reusability and expendability of that platform. They go, okay, I'm going to launch this. If it works for 2-3 years, that's perfect, because I'm going to launch 20 more of these things, because the launch costs themselves are not the driving factor. It's the speed at which you can get the platforms done. It's the cost, removing the NRE, and it's leveraging the capabilities we already are working on and have been for decades. So there's some references here of some of the programs I've talked about that are on, some of them on the third-party side from NASA and others that shows examples of how Mil-Aero platforms were used for some of these space applications. And then lastly, in terms of the Aitech plug itself, I think a lot of people are familiar with Aitech, and we're excited with the 40 years of experience and looking forward to continuing that and supporting the embedded community, both Mil-Aero and space, as we move forward. And with that, open to any questions either here or in private.